Now let's see if we can't figure this problem out. So we have something like an airplane that is traveling north 29 degrees east. Now, from my understanding, obviously not an expert in this, but if that's north 29 degrees east, change colors, would be something like this. So I think this is the 29 degrees east. I'm not sure how my camera's, I don't know which way I should point, but this way, 29 degrees towards east. So I think that is 29 degrees. Okay. So they did that for 1/4 of a mile. So the length of this is 1/4 of a mile. And then it says that they turn 90 degrees to request permission. We don't really need that. They go 90 degrees and they do that for 1 mile. So I'm going to change colors and it's going to be just a big old turn right there. And that's 90 degrees from there. Okay. So it looks like this angle here is 90 degrees. The question asks what bearing control. So I think it's what's the original angle or the angle from the original position, which we're going to call the origin there. Okay, so that's the idea. And we know that this is 1 mile, so that helps a lot. Okay, I think that's good. Okay, so now we have to solve it. What do we know? We know that this here is 29 degrees, but we don't know what this angle is really. So we need to find that. That's the angle from mission control, I suppose, or whatever they call it. So let's see if we can't find it. Now we know that this is 1 mile. We know that this is 1/4 of a mile. So I could find um, the missing angle by using a calculator and also my trig function. So I think from there, we could say that the tangent of the missing angle would equal 1 mile over 1/4 of a mile. So I think that will get us, but we don't know what this angle is. We're going to have to solve. So 1 over 1/4 would be 4. So this is tangent of theta equals 4. Okay. Now, I don't know what that is, so I need to plug that in my calculator because I don't know the tangent of 4. I know the tangent of 4 pi, but I don't know the tangent of 4. So I'm just going to tell my calculator that they need to figure out this angle for me. And so I'm going to put 4, and I want inverse tangent, which tells me the angle. And so I have something like 75.96 is, and I'm in degree modes, by the way. So the angle is approximately 75.96 degrees. Okay. But that's not the angle they asked for. They asked for the angle from mission control, but now we have that angle and we're only missing one angle now. So the whole triangle has to be 180 degrees. We already know about this guy, this tangent of, I'm going to say inverse tangent of 4. I'm gonna plug it in my calculator precisely, but we know it's about 75. And then we also know there's going to be, oops, I wrote the wrong thing. Control Z, Control Z. We know that there is a 29 degrees inside that triangle. Okay, so now I'm going to ask my calculator to calculate this angle, and this is the angle I think we are seeking. So 180 minus the inverse tangent of 4 minus 29 degrees, and that's going to be 75.04 if we rounded. So approximately equals 75.04 degrees. How are we supposed to answer? The control tower should be using south going down. 75, that's where we are, east, okay? So southeast, that should do it. Okay, so I hope, hope that helps at least understand these bearings application problems, okay?